Okay, the next topic in R that we're going to look at is the principal component analysis. Okay, so we're going to generate the PCAs in R. Okay, the principal component for all predictors except for the first three that are nominal. Okay, first we have to read the data, and we're going to use the serial data for this. So serial dot df, right? Read dot csv serial dot csv. Okay, so run that, and it gave an error. Okay, so apparently serials. So I missed it. S there. So read that. So that's come in. Okay, if you look at the data, you see the first column, the second column, and the third column. These three are character columns, so we can't use them in principal component analysis. So we can do a structure for serials, and that will also tell you the same thing. So character, character, character for the first three, and the rest of them are either integer or numeric values, so which is good. So what we have to do, the command is pretty straightforward. So we do say PCS PR component. Principal component is the function that we use, and we give serial.df. Okay, so now remember we have to remove the first three. So all the rows, and then 1 to 3 should be minused out. But here there is one problem, and that is some of these variables have missing values. Say for example here, see there is a missing value there. So we need to specify what to do with missing values. So we have to say for the data set, so NA, so that's our missing value, dot omit. Okay. So here there is a problem. The parenthesis for C, and then you have the square bracket, and then the end. Okay. So this is going to omit all the rows with missing values. Now you run. Okay, I'm missing one more parenthesis, so I'm going to cancel that out. So this is for the omit, so I need one more. Okay, so now PCS results are saved in a list, and then we can okay, the things that we are interested in is rotation and the axis. So we can view those. We can take a look at just those. So let me move that over here. Okay, so all right. So now we want to look at. So if you do a summary of PCS that we just created, that's going to give you for each PC there are 13 variables. Okay, so we have serials data, there are 16 variables. We took away 3, so there are 13 variables. So 13 principal components are possible. So here is our summary, and if you look at the cumulative variance proportion, you see after the fourth PCA, you have within 4 PCs, we have 99.9% of the variance captured. Okay, and if you want to look at the PC values themselves, so we can say PCS rotation. Okay, so that will give you the values for each of the variable. Okay, for each of the 13 PCs. Okay, but if you want to just look at just at the top few, then you can specify I want, okay, all the values, okay, for 1 to 5. So you get all the variables 1 through 5, and you can round it to some decimal places if you like. And if you want the principal component scores, you can do that by PCS X. See, we have PCs 1 to 13, and you have 77 the variable. So these are the principal components that you can use, and you can convert this into a data frame. And suppose we want only the first 4, we can say scores data frame. Okay, and then we can convert it into data frame, right? PCS X, we want all, say 1 to 4. All right, so now we have scores DF. We have only the first 4 principal components, okay, and the entire data set. So this is how you would peel off just what you want. There is one thing that we have to look at, and that is very important in principal components, and that is you want to standardize the variables before running principal components. So we're going to use the same command, same function, right? In PR component, right? Scale is a function that we can use. Scale, if you say scale is true, then all the numerical variables will be standardized, and then we will run the PCS. Okay. Now suppose and after that you can run. Okay, let me put that here. Okay. And then if you run, then you'll have the scores after with principal components generated after standardizing the variables. All right.